This is video 2 of the go through lesson for worksheet 7.4. So here I will cover page 3 and 4. Okay, now for question 5, it is actually a very straightforward question where you need to know what it means by most work. So work done, all of these are referring to energy, and to be specific is energy transfer. So if you refer to the formula power equals to energy over time, you can actually find the energy equals to power times time. So to solve this, basically you just need to check your A, B, C, D and to find your energy by multiplying the power to the time, and you will get a third column where you have a row that will tell you with the greatest work, which is your energy. For question 6, it is pretty hard. So I will go through every option and explain to you why they are wrong or correct. So first, let's recall we are looking for a statement that's not true. So let's look at the first option, which is the kinetic energy is 100 kilojoules. So this is the easiest because you just need to apply your KE formula, half mv square. You have the mass, which you can substitute into here. You also have the speed, which you can substitute into here, and indeed you will get 100 kilojoules, which is 100,000 joule. So this part over here is actually also true. Now let's look at your option B. Alright, if you look at your option B, it says that the resultant force is actually 0 Newton, right? And how do I know that? If you see the color coding, the yellow, if you have constant speed, basically what you are seeing is that the acceleration is 0. And if you can recall, you have learned this formula called F net equals to ma. So if your acceleration is 0, it means that the resultant force must be 0. So therefore, it must also be true. Alright. Next, let's look at the fourth option, whereby the work done by the burning of fuel is whereby the work is done by burning the fuel in the engine. So as I hope you know that the car derives its energy from the fossil fuel that is stored in the engine. So actually this fuel in the engine must be the energy source that the car derive its kinetic energy from. So the fuel in the engine has your chemical potential energy, which upon burning, it will turn into work done. So what is work done? Like I say again, work done is energy transfer. So when you burn the fuel, the chemical potential energy is being released. This energy being released, some of it will heat up the engine, some of it will be transferred to the car. So this work is done is trying to tell you that there is energy transfer, right, from the engine to the car, and that must be true, right? Because that is how the car gets its kinetic energy. So we know that D is also true. So let's look at C. What's wrong with C and why is it not true? So if you think about it, you will notice something very strange in C, because you can see that these 100 kilojoules and these 100 kilojoules are the same. And previously in the D explanation, I am saying to you that the energy from the fuel must be responsible for the kinetic, is responsible for the kinetic energy of the car, right? Meaning that I would expect whatever energy that released by the fuel must be converted to kinetic energy. So you may ask, Mr. Choi, you just say that kinetic energy is 100 kilojoules. I try the formula, substitute it makes sense. And then in D, you say that the energy from the kinetic energy must have come from the fuel. So isn't C a direct consequence of A and D? And shouldn't C be correct then if A and D are correct? Now, like I said, when I'm talking about D, I said that the chemical potential energy released by the fuel, some of it will heat up the engine. That's why your engine becomes hot, right? When you touch the car boot, the front part of the car. And some of it, most of it, will turn into kinetic energy, which will move the car. So if we look at this, it means what? It means that your chemical potential energy from the fuel, upon burning, will turn into kinetic energy, will turn into work done, transferring it to the car, which is then converted into kinetic energy. And from A, we know that 100 joules of energy are used as kinetic energy. So we know that is 100 joules already moving the car. But at the same time, I also know that when we burn the fossil fuel and release the chemical potential energy in it, some of the energy will be lost to the surrounding. For example, like the engine block will absorb some of this energy and it will heat up, right? And at the same time, because there's moving part in the engine, it means that sound energy is produced because it's vibrating, there's moving part and all that, right? So you know that some energy must be lost as sound energy and heat, meaning that maybe there is 20 joules of energy that is being used as sound and being used as heat. So what does it mean? If I have 100 joules of energy as kinetic energy, 20 joules of energy being lost to the surrounding as heat and sound, it means what? It means that this chemical potential energy must be the summation of 120, right? It's 120, right? So it means that my chemical potential energy is actually a sum of the Ke and whatever energy loss that I need to account for. So because of this argument, we would know that the total energy, right, that is produced by the field must be more than 100 kilojoules, not equals to 100 kilojoule. And that is also why they put this keyword here. They are telling me the total that is being released by the field. Yeah. Okay, let's move on to question 7. Okay, for question 7, we are seeing that Mary is jumping on a trampoline, and that you can see that the question has kindly defined for you that at this point at A, this is when your H is equals to 0, right? So we can see that at point B, there is actually a gain in GPE, and there is also a gain of kinetic energy, because at this point of time the gymnast must be actually moving with some speed. And then down here, because this is the max height, you can say that your speed is actually equals to 0. So once you have this great grand idea of things, you would be able to solve this with no issue. So for part A, you are actually asked to find the work done on Mary by the trampoline. And actually in this question, the force from the trampoline on Mary is given. So actually you can apply the work done formula directly. And you are also given the parallel distance that the spring force is acting along. So this spring force, right, has acted on Mary for 0.6 meter. So you can actually multiply them and get the answer. For part B, like I said, when Mary reaches B at this point, there is actually both GPE gain and kinetic energy gain because of this height of 0.6. So we know that these gymnasts are getting the energy from the work done by the trampoline or by the spring. So in another word, you can actually use whatever you get from part A, and this energy is actually being converted into kinetic energy and GPE. And you'll be able to find your kinetic energy as 210 joules 2SF. Then for part C, most of you can actually tell me that at part C, all the kinetic energy must be converted into GPE. And you already know that all this energy has actually come from the spring, right? All these A, whether you're at A, whether you're at B, whether you're at C, all this energy originated at A, right? So because of that, I am using A as my reference point, right? So because of that, I would have written down 480, which is the amount of energy that I start with at A, and I say that whatever energy I have in A has now completely turned into GPE, right? But take note, when I measure the GPE, I am measuring it from A, which is here. But what the question wants me to measure, which is this maximum height, is here from B to C. So actually when I calculate, when I do this calculation, and I managed to find capital H, I will actually come to a value of 1.07, and if I want to find the small h in green, I need to minus 0.6 from it. That is why most of you are getting it wrong. So I just want to use this question to highlight to you, when you find h, you need to be very mindful where h is being measured from. So from the formula, h is actually measured from A, but the question actually want a height that is coming from B to C. Yeah. Okay, most of you are getting question 8 correctly. Many of you are being able to see that actually the whether you are in the left hand side situation or the right hand side situation, what happen is that the box will gain the same amount of GPE because the amount of height increase is the same. Okay, so if you have problem with question 8, after even looking at this diagram that I'm showing you now, you can just WhatsApp me and let me leave a message, voice message, text message, and let me know whether you understand it. Okay.